Welcome to The Explainer. Today, we're not just solving equations, we are learning how to be the symphony conductor of your mathematics exam strategy. Specifically, we're targeting the Cambridge AS and A-Level Mathematics 9709 syllabus, and we're zeroing in on one of the most notoriously tricky, high-stakes areas of Paper 2, non-real roots and complex conjugate pairs. Listen, whether you're building foundational algebra skills in syllabus codes 0580, 4024, or 4040, pushing into the advanced territory of 0600 or 4037, or even stepping up to further math in 9231, what we're talking about today is the absolute pinnacle of that journey. It's the 9709 standard. I want you to imagine a real past paper question right now. You're asked to solve a cubic equation with real coefficients, given that one root is 3 plus 2i. Let me introduce you to two types of students I see all the time. First, there's Alex. Alex overloads his paper with raw mathematical facts. He immediately writes down 3 minus 2i because he memorized the rule, but he provides zero analysis or procedural proof. Then there's Sam. Sam rushes in a panic, completely misses the command word show that, and scribbles down a messy long division that ends nowhere. Both of these students lose massive marks. They have the mathematical instruments, but they have absolutely no idea how to orchestrate their arguments, so each paragraph, each step, plays in perfect harmony. Today, we're going to fix that. Now, I need you to understand exactly why we are focusing on this today. Look at this number, 15%. What's really interesting and honestly a bit intimidating about this slide is the sheer weight of this single topic. Complex numbers, and specifically the evaluation of non-real roots, account for approximately 15% of the total marks in Paper 2. Think about that for a second. 15% is not a marginal topic that you can just hope doesn't show up. That is a grade-defining chunk of your paper. That is the literal difference between a B and an A star. If you don't have a concrete, bulletproof strategy for handling these specific questions, you are leaving a massive amount of points on the table for the examiners to just sweep away. But don't worry, because by the time we finish this session, you are going to know exactly how to secure every single one of those marks. We are taking the guesswork entirely out of the equation. So here's our masterclass agenda for today. First, conjugate core principles. Second, the procedural framework. Third, critical analysis tools. And finally, top examiner warnings. Let's move straight to Section 1, Conjugate Core Principles, the foundation. Okay, the crucial point here is understanding the core definition. Non-real roots always occur in complex conjugate pairs. If you have a polynomial with purely real coefficients, and you know that x plus iy is a root, then its conjugate, x minus iy, is automatically a root as well. This happens because when you multiply those two roots together, when you expand z minus the first root times z minus the second root, the imaginary parts cancel out perfectly, leaving you with a real quadratic factor. It's beautiful, really. But knowing this definition isn't enough for Cambridge. Remember our student Alex? Alex just writes the conjugate down and moves on. But examiners explicitly note that students find evaluating this evidence and drawing conclusions on paper particularly challenging. It's not just about finding the pair, it's about the systematic analysis required to prove why it's the pair. You have to use evidence-based reasoning. This is where we adopt the Peel framework for mathematics. P-E-E-L. Point, evidence, explanation, link. Your point is stating the conjugate root. Your evidence is showing the algebraic expansion to create that real quadratic factor. Your explanation is stating that because the coefficients of the original polynomial are real, this rule applies. And your link is using that quadratic factor to divide the main polynomial and find the remaining roots. That's how you orchestrate an answer. And hey, before we continue, subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. As we can see on this slide, mastering this topic means hitting three very distinct cognitive domains. The examiners are rigorously testing your knowledge and understanding. Do you actually know what a conjugate pair is? And do you understand the fundamental theorem of algebra behind it? Then they test your application. This is where our other student, Sam, usually falls apart. Sam might know the rule, but applying it under time pressure to find a missing root or coefficient is a different beast entirely. Can you apply the sum and product of roots accurately? And finally, analysis. Can you interpret the relationships within the mathematical data to draw a valid conclusion? When you get a discriminant that is less than 0, meaning b squared minus 4ac is negative, can you analyze what that means for the intersection of a curve and a line? You are proving your theoretical understanding and your analytical skills simultaneously on the page. It's a multi-layered assessment, and you have to prove to the examiner that you are firing on all cylinders across all three domains. Moving forward, let's jump into Section 2, the procedural framework. Execution. Let's break down these 5 steps. This is your exact mathematical success blueprint. Step 1. Deconstruct the question. What is the command word? Is it solve, show that, or find? If it's show that, you cannot just skip to the end. The entire mark allocation is in the journey. Step 2. Extract relevant data. Pull out the given roots or coefficients and write them clearly at the top of your workspace. Step 3. Select your analytical framework. Are you going to use the factor theorem, or are you going to expand the roots and compare coefficients? You have to make a strategic choice here based on what will be fastest and least prone to algebraic errors. Step 4. Execute with clear notation. This is absolutely vital. Use clear brackets, keep your real parts and imaginary parts distinct, and expand binomials meticulously. And finally, Step 5. Present with correct terminology. Make sure your final answer is exactly what was asked for. Following this exact sequence, step by step, transforms a messy, panicked scribble into a masterclass response. It signals to the examiner immediately that you are a top-tier candidate who is in complete control of the mathematics. Stop right here and burn this quote into your memory. This is straight from the principal examiner reports. Students lose marks by not showing working. Listen to me carefully. The method mark strategy is your ultimate safety net in the Cambridge 9709 exams. You could make a simple arithmetic error, maybe you dropped a negative sign when squaring I, forgetting that I squared is -1, at the very end of a massive complex conjugate problem. If you just write down the final answer, you get a 0. But if your methodology is laid out clearly, showing the exact steps of your Peel framework, you will still scoop up the vast majority of the marks. This is where you orchestrate your defense against simple human errors. And actually, since we are talking about saving your grade, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. This text comparison clearly illustrates exactly what we've been talking about. On the left, we have the final answer only approach. This is what Alex does. He does a bunch of complex arithmetic in his head, scribbles z equals 2 minus 3i, and moves on. The calculation was slightly off. Result? 0 marks. All that mental effort for nothing. On the right, we have showing procedural working. The student starts by explicitly stating the conjugate root. They show the multiplication of the 2 linear factors to form a real quadratic. They show the long division of the cubic polynomial by that quadratic. They find the final linear factor. At the very last step, they mess up a simple addition. But because their entire thought process is visibly orchestrated on the page, the examiner sees their cognitive domains in action. The red pen marks of a wrong final answer transform into the green check marks of method marks. They walk away with 4 out of 5 marks instead of 0. That is the power of procedural working. Let's transition to Section 3, Critical Analysis Tools. Deconstruct, solve, evaluate. We are moving into our interactive workshop phase. I want you to imagine a complex mathematical data source right in front of you. A 60-second visual countdown camera is ticking. You are looking at a cubic equation, z cubed minus 5z squared plus 8z minus 6 equals 0. You are told 1 minus I is a root. How will you scan this? Step 1, break the problem into logical steps. You instantly extract the core trend. The coefficients are real numbers. Therefore, the conjugate pair rule applies. The other root is 1 plus I. Step 2, solve systematically. You multiply z minus 1 minus I and z minus 1 plus I. You expand carefully, remembering I squared is -1, you get z squared minus 2z plus 2. Step 3, check for reasonableness. Did your imaginary terms completely cancel out? If you still have an I floating around in your quadratic factor, you've made a mistake. Stop, find the flaw, and fix it before you proceed. Step 4, make justified recommendations, or in this case, justified conclusions. You state clearly that the remaining factor must be linear, and you find it. This specific problem-solving sequence guarantees that you don't go down a 10-minute rabbit hole of wrong algebra. Let's keep the workshop going. Imagine a 30-second speed writing timer is on the screen right now. You have to write one perfect paragraph justifying your mathematical process. Top-tier evaluative thinking requires you to look beyond the basic numbers. It's about questioning given assumptions. Did the question actually state the coefficients were real? If it didn't, you can't assume the conjugate root rule applies. It's about considering different mathematical perspectives. Could you use the factor theorem here? Yes. Could you use the relationship between the roots and coefficients, like the sum of the roots equaling -b over a? Absolutely. Which is more efficient for this specific problem? Comparative analysis requires you to justify every single decision with concrete mathematical evidence. You don't just say, I used long division. You demonstrate the long division, and you explain that the remainder is 0, therefore proving it's a true factor. The examiners are desperately looking for that level of mathematical maturity. They want to see the conductor guiding the orchestra, not just someone randomly banging on a drum. For our final section, let's look at Section 4, Top Examiner Warnings, Pitfalls to Avoid. We are pulling directly from the principal examiner reports here to reveal the exact places where students needlessly throw away marks. If you want to maximize your grade and hit that 100% mark potential, you absolutely must avoid these top 3 mistakes. First, forgetting the proper format for complex numbers. Unless told otherwise, you must present your final answer in the strict x plus iy format. If you leave it as a messy fraction with I in the denominator, you haven't finished the problem. You need to multiply by the conjugate to rationalize that denominator. Second, poor presentation and annotation. If your z looks like a 2 or your I looks like a 1, the examiner cannot confidently follow your algebra. If they can't read it, they can't award you those precious method marks we talked about. And third, failing to be specific to the context. Always tie your mathematical findings back to the original question asked. If they asked for the roots on an Argand diagram, don't just calculate them. Draw the axes, label the real and imaginary parts, and plot them correctly in the right quadrants. All right, I want to give you a quick memory hack to lock this entire system into your brain. I challenge you to invent a mnemonic right now using the first letters of our 5-step procedural framework. Deconstruct, extract, select, execute, present. DESEP. Maybe it's does every student expect perfection or deconstruct equations so exams pass. Whatever it is, create a memory hook. The moment you sit down in that exam hall, flip open paper 2 and see a question on complex numbers, your procedural framework needs to kick in automatically. And listen, students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. You have to build the muscle memory. So I leave you with this ultimate provocative question. Will you secure that massive 15% of paper 2 by meticulously showing your working and orchestrating your arguments? Or will you let a simple formatting trap or a missed command word cost you your target grade? The blueprint is entirely in your hands now. How will you execute it? Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCS and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.